first law of thermodynamics. How do we transfer energy from one system to another? And how do we write an energy balance for a system? We define heat as being the transfer of energy due to a temperature difference between the system and its surroundings. All other forms of energy transfer will be classified as work. So this would include mechanical work, electrical work, chemical work, and so on. If we have a system, everything outside is known as the surroundings, and these are separated by the system boundary. We can have energy transfer in the form of heat, denoted by Q, or in the form of work, denoted by W. The sign convention that we will adopt is that all energy transfers to a system are positive. All energy transfers from a system are negative. We can have multiple streams of heat transfer to a system, and we'll denote this by Q1, Q2, Q3, Q4, and so on. If we add all of these up, that is the net heat added. In the same way, we can also define the net work done, W net, by summing up all the streams of work. We define power as being the rate of doing work. This will be denoted by W dot, which is equal to delta W by dt. The units of power would be joules per second, and we call this a watt. The rate of heat transfer is Q dot, which is delta Q by dt, and the units of this are also the same as that of power, watt or kilowatt. The heat transfer per unit mass of a system is denoted by a lowercase q, and it is equal to Q upon m, where the uppercase Q is the total heat transfer and m is the mass of the system. Similarly, the work done per unit mass of the system is denoted by a lowercase w, which is equal to the work divided by the mass of the system. It is important to remember that Q and W are not properties of the system because heat and work are not properties. We have macroscopic forms of energy, and these are the potential energy and the kinetic energy. All microscopic forms of energy are classified as internal energy. The total energy of a system, E, is therefore the sum of the potential energy, the kinetic energy, and the internal energy. We can now state the first law of thermodynamics as saying that the change in energy of a closed system equals the net energy transferred to it in the form of work and heat. So if we show the heat and the work being added to a system, this produces a change in energy, delta E. And Q plus W must equal delta E. This is a statement of the conservation of energy, which says that any energy transferred to a system must show up as a change in the energy of the system. The energy cannot be created and it cannot disappear. The change in energy, delta E, is the difference between the final and the initial energy of the system. We can write the first law in terms of infinitesimal energy transfers by saying that delta Q plus delta W must equal dE, where dE is an infinitesimal change in the energy of a system. We can also write the first law as a rate equation by saying that Q dot plus W dot equals dE by dt. To summarize, the total energy of a system, E, is equal to the potential energy plus the kinetic energy plus the internal energy. Heat is a transfer of energy due to a temperature difference. Work includes all other forms of energy transfer. The first law of thermodynamics says that the change in energy of a closed system equals the net energy transferred to it in the form of work and heat. We can write this mathematically as saying Q plus W is equal to delta E, where delta E is equal to delta PE plus delta KE plus delta U.